Today we are going to start new topic, interference. What is interference? So before knowing what is interference, we will see what is principle of superposition. So what is principle of superposition? You might have studied in what is principle of superposition. It is nothing but, suppose there are two waves traveling in the medium. So the disturbance created by the first wave, if there are two waves y1, y2 are traveling in the medium, y1, y2 traveling in the medium. Okay, so the disturbance, this is the first wave, it is traveling, this is the second wave, the traveling. So the disturbance created by the first wave is given by y1, the disturbance created by the second wave is given by y2. So the superposition is nothing but the combined disturbance created by the sum of y1 plus y2 is nothing but y. It will give you the total effort. That is called as a principle of superposition. Okay, it states that the resultant displacement of the particle acting upon, it can be two waves or more than two waves acting simultaneously on the medium. So that is called as a principle of superposition. So that is called as a principle of superposition. Suppose this is the first wave which is traveling. So this is the first wave which is traveling. This is the second wave which is traveling. So what is happening here? What is superposition? It is nothing but this is the first wave, this is second wave. So the resultant of this wave is given by this one when both are in phase. So superposition can be, the waves can be in phase, or in the, this is the condition, the second condition, that when there are in out of phase, amplitude is becoming 0. So interference will be, what is interference? Interference is based on the principle of superposition. If this is the first wave, this is the second wave, when both are in phase, this is the disturbance, this is the wavelength of the first wave, this is wavelength of the second wave. So the amplitude of this wave and this wave combinedly, the resultant wave y is equal to y1 plus y2 is given by this one. Okay, when the waves are in out of phase, we are getting, when wave out of phase, we are getting the amplitude, here it is becoming maximum, here it is becoming minimum. So based on this principle of superposition, where interference is taking place. So suppose this is what is happened. What is interference? Interference is nothing but when two waves are traveling, there is constructive interference will be taking place at one point and destructive interference will be taking place at another point. So this is called as a, this is nothing but interference of light. What is interference of light? When two waves are superimposing on each other, then what is happening here? The at one point where amplitude, when both waves are in phase, we are getting a constructive interference. Constructive interference is taking place, and when two waves are in out of phase, destructive interference is taking place. So interference is based on the principle of superposition. Okay, so for example, we can see the two waves. This is the first wave, this is second wave, this is first wave, and these two, this is the green one is one wave and this is another wave. Okay, so what is happening here? Here, when, because the blue and green are, the blue and green are so here we are having the blue one, here we are having the blue and green. These two are waves are going on. So here the second figure we can see, this is how constructive interference taking place. The resultant is given by the green wave. So this is nothing but how interference is taking place. Okay, so what is interference? Interference is nothing but it is based on principle of superposition. So what is principle of superposition? When two waves are traveling in the medium, so the disturbance created by the first wave are y1, disturbance created by second wave is y2. So the summation of the two waves is, it will give you resultant of the two waves. When the waves are traveling in same direction, it will be nothing but we will get this kind of a, the amplitude will be increased. If it is traveling in out of phase, the amplitude will become 0. So based on the principle of superposition, we are getting constructive interference will be taking place and destructive interference will be taking place. So interference is nothing but it is based on superposition of the waves. It is based on superposition of the waves, where the modification of distribution of intensity in the superposition is called interference. At one wave where amplitude is becoming maximum, it is called as a constructive interference. When amplitude is becoming, the difference of the two amplitudes will give you the destructive interference. Because what we are talking about light. Constructive interference, we will get a bright light will be there. At destructive interference, we will be getting a dark light, or light will be of less intensity. So we will see the next topics. What is Young's, the interference can be, the Young's experiment will show us how interference will be taking place. Okay, so this is a Young's double slit experiment. Okay, this is a Young's double slit experiment. This is a source. This is a cardboard. We are making a pinhole. This is second cardboard. We are making a two pinholes. So whatever the light waves are there, they're traveling from single slit. They're again distributed into S1, S2. They are distributed like this, and we are placing a screen here. So whatever the interference pattern is there, that is displayed on this one. So what is happening here? For interference to take place, the light is, we are getting the source is this one. It is coming from single slit. It is divided into two parts. It is coming from S1, S2. Overlapping is taking place. We are placing a screen here. Here on the screen we can see this green one is the bright fringe. This is the dark fringe. That means constructive interference is taking place at the points of yellow color. This will show us the constructive interference, where we can see bright light. This will show us the destructive interference, where we are getting a darker lines. So alternative dark and bright fringes we can see using this Young's double slit experiment. Okay, what is Young's double slit experiment is nothing but what we can see the light from a single source is split into two sources. From same source the light is coming. It is split into S1, S2. Okay, and so the waves from S1 are traveling like this, the waves from S2 are traveling like this. They are traveling certain distance, and on the screen interference pattern is taking place. See here we can see the how interference is taking place at this point, and here the waves are in phase with each other, where we are getting maximum intensity. Here we are getting a minimum intensity we are getting at this point. So alternatively dark and bright fringes we can see when we place a screen at this point. So this is nothing but about Young's double slit experiment, which shows how interference pattern is taking place, and how we can see the interference pattern, on a screen. This is nothing but Young's double slit experiment. So next topic is coherent sources. What is meant by coherent sources means, see, this is nothing but the waves which are coming are in phase with each other, or they are having a phase difference, same phase difference is there. Those kind of lights are called as a coherent light. And what here the light waves are not in phase with each other. This is called as a incoherent light waves. This is called as a coherent light waves. So for interference pattern to take place, we require the source must be coherent, and that means they must be in phase. There must be a constant phase difference must be maintained between the two light rays S1 and S2. Then only interference pattern can take place. So takes place. So this is called as a coherent light waves. These are called as a incoherent light waves. Okay, example of this is nothing but incoherent light waves. This from sunlight, the light will be coming out, all the colors will be there in the sunlight, they will be in this pattern. Okay, so one more example of coherent light is we are having a here from a LED light, whatever the light rays are coming, like they are like this, they are incoherent, and the laser light where the light waves are coming like this, these are all in phase with each other. So this is a incoherent light, this is also incoherent light, and this is a coherent light. That means they are in phase with each other, or constant phase difference is maintained throughout this line from here to here. Whatever the time is there, whatever the time they are in phase with each other, they are not in phase with each other. So this is example of a coherent source and incoherent source. Okay, for interference pattern to take place, there are two conditions. One is a spatial coherence must be there and temporal coherence must be there. So the difference between spatial coherence and temporal coherence is this is example of, so this is example of a incoherent light. From a normal bulb, whatever the light rays are coming, they are like distributed like this, though this is nothing but incoherent light. That means one on one wavelength, another wavelength is, the distance is not maintained, the phase is not maintained here, so this is called as a incoherent line. So here this is called, for interference pattern to take place, we require a spatial coherence as well as a temporal coherence. What is spatial coherence means? See, this is called as a spatial coherence. That means the distribution of light is taking place evenly, the space is taking place evenly, so this is called as a spatial coherent. This is nothing but a this is nothing but an example of a spatial coherence. So for interference to take place, we require the source must be coherent. So one more condition is, what is happening here, the phase condition of two sources, it must be spatial coherence must be there, temporal coherence must be there. So we'll see that what is meant by spatial coherence means, see if we see Young's double slit experiment, if we go to Young's double slit experiment, if we go for Young's double slit experiment, so what is happening here, the distance must be, and S1 S2 must be fixed, if the pinhole must be very small. So if the pinhole is large and distance maintained is not properly, so whatever the diffraction, whatever the interference pattern which we are getting, alternate dark and bright fringes, so this contrast we will not be getting. So that is called as a spatial coherence. So for spatial coherence, what is happening here, the pinhole opening S1 S2 must be the same and distance must be maintained. If the phase difference of any fixed point, it should not vary with time, then it will exhibit spatial coherence. And what is temporal coherence means, what is the distance from S1 to, the distance from the source to the screen must be fixed. If the suppose in between, if we are having any obstacle also, it will affect the diffraction pattern, it will affect the interference pattern. So this is nothing but the temporal coherence and the spatial coherence. So for these are the two basic condition or two necessities for interference pattern to take place. We must be having a spatial coherence as well as a temporal coherence. And next we will see the condition for interference. For condition for interference, there are three conditions. To a condition for sustained, condition for sustained interference, condition for observation, and condition for good contrast. For sustained interference, we require temporal coherence as well as spatial coherence. And for observation of the fringes, what we require, the distance maintained between with the screen, where the screen is placed, the background must be dark and the distance D must be large, then only we'll get the nice fringes. And good contrast, to maintain the good contrast, the sources must be the S1 and S2, the amplitude of S1 S2 must be equal or nearly equal. So these are the conditions for interference, these are the first conditions for interference.